Okay, in this chapter, we're gonna study the numerical measures to describe the data. In the last chapter, we tried to transform a massive, raw data into a meaningful form. We organized the quantitative data into a frequency distribution and tried to portray it graphically in a histogram. In that way, in using frequency distribution, we can find the concentration of the data. This chapter, we are concerned with two numerical ways of describing the quantitative data. It's measure of location and measure of the dispersion. Measure of the location is try to find, help us try to find the center of a group of data. Often refers to as the average. Measure of the dispersion, often called the variation of the spread of the data. It's very hard to understand what's the measure of the location or measure of the dispersion, but here there is a very good example to show you what the dispersion mean here. Average annual income of executives for the internet-related companies is $80,000, and for the pharmaceutical firms is also $80,000. The salary, so now we know the average number for both companies, they are the same. We cannot tell any difference. But the salaries for the executives in the internet firms range from the 70,000 to the 90,000. Well, in the pharmaceutical companies, it ranged from the 40,000 to the 120,000. What does that mean? That means even though the average salaries are the same for two companies, but there is much more spread or dispersion in salaries for the pharmaceutical executives because it ranges from the 40,000 to the 120,000, where the first company is from 70,000 and 90,000. That's a difference. About the measures of the location, we're gonna learn the arithmetic mean, the weighted mean, the median, and the mode. All of these measures help us to find out the center of the data. Measures of the dispersion, we're gonna learn the range, the mean deviation, and the variance, and the standard deviation. For the mean, remember, you have to know how to calculate the mean. The first one, population mean. So for ungrouped data, remember, for ungrouped data, the population mean is the sum of all the population values divided by the total number of population values. And we have to memorize all these letters which represent, the different characteristics. We use mu represents the population mean. So please remember we use mu represent the population mean because we use different letters to represent the sample mean. N here is the number of the values in the population. This x represent any particular value. We call this one sigma. So sigma indicates the operation of ending. Sigma indicates the operation of ending. So sigma x is the sum of the x values in the population. The mean is the most widely used measure of the location. The major characteristic about the mean is all values are used because we're gonna sum all the values in the population, right? It is unique. What that means for a group of data, there is only one mean. The sum of the deviation from the mean is 0. I will explain it in the later slides. It's calculated by summing the values and divided by the number of the values. We already got that from the form. Now let's see how do we calculate the population mean. Here is the example. Please read the examples and say the question. Let's check the question. Is this for information a sample or population? What is the arithmetic mean number of patents granted? So here is a population. Why? Because it's considered all the values in this data. In this consider all the values. It's not taken sample from the population. So how do we get the mean of it? We write down the formulas. Mu equal to sigma x divided by n. So that means sigma x means we add all the values in the group up, then divided by the number of the values. So there are 12 values here, and we add each individual value up. So we get the 2340 and divided by 12, we get 195. This 195 is the population mean for this population. Here we have to know about two terms. One is a parameter, one is a statistic. What's parameter? Parameter means any measurable characteristic of a population. For example, the population mean we just introduced is parameter of a population. Statistic is a measurable characteristic of a sample. So if we find out the mean of a sample, that mean is a statistic. In this slide, we introduce the properties of the arithmetic mean. So we already know there is only one mean in the population. And another thing is I want to explain is the sum of the deviation of each value for the mean is 0. What does that mean? So we can consider the mean as a balance point for a set of the data. To illustrate, we have a long board with the numbers 1, 2, 3, 4, 5, 6, 7, 8, and 9, evenly spaced on this board. Suppose 3 bars of equal weight were placed on the board at numbers 3 and 4 and 8. Okay, 3, 4, and 8. So what is the mean? What is the mean for the values 3, 4, and 8? Is 5. How do we find that? It's 3 plus 4 plus 8, then divided by 3. We get 5. So we put the balance point, we set the balance point at the 5, and that's the mean of these three numbers, 3, 4, and 8. So we would find that the board is balanced evenly, perfectly. The deviation below the mean, okay, the deviation below the mean means 3 and 4 are equal to the deviation above the mean. The 1, 2, 3. Above the mean, there are 3 deviations. Below the mean, from 3 to 5, from 4 to 5 from 4 to 5 together is 3 deviations. So these 3 and these 3 are balanced off. So that means the sum of the deviation of each value from the mean is 0. Okay, now let's find out the sample mean. Means we try to find the mean for a sample. For ungrouped data, remember it's for ungrouped data. What's grouped data? Grouped data is what we learned from the last chapter. It means we turn a group of raw data into the frequency distribution. Once we put the data into the frequency distribution, we call that grouped data. Okay, so for ungrouped data, the sample mean is the sum of all the sample values divided by number of sample values. We use X bar. We call it X bar. We use X bar represent the sample mean. And X bar equal to sigma X. X is any particular value in the sample. Sigma X divided by N. N is the number of the values in the sample. And sigma X again is the sum of the sample values. Here example for the sample mean. How do we get the sample mean? We use the sum of all the values in the sample divided by the number of values in the sample. So x bar equal to sigma x divided by n. What does that mean? That means we end all the sample values up. 90 plus 77 plus 94 plus 89 plus 119 plus 112, all of those values number up, then divided by 12. There are 12 values in this group of data, so we get the 97.5. That's the sample mean. Next, weighted mean. Weighted mean occurs when there are several observations of the same value. The definition for weighted mean is the weighted mean of a set of numbers x1, x2, x sub n, with corresponding weights w sub 1, w sub 2, until w sub n is computed from the following formula. Use this formula. So it looks like hard to understand, so let's check an example. It will be a lot easier to. This construction company pays its hourly employee $65, $19, or $25 per hour. There are 26 hourly employees, 14 of which are paid at the 16.5 rate, 10 at the $19 rate, and the 2 at the $25 rate. What is the mean hourly rate paid the 26 employees? So we find out the some observations with the same value, like 14 observations with the same value, what value they paid at the same rate. Okay, 10 observations had the same value, they paid at the 19 rate. So how do we find out the weighted mean for this group of the data? Is x bar equal to 14, okay, 14 observations times 16.5, that's the same value they shared, and plus 10 observations times 19 is the same value, and plus 2 times 25, because 2 people paid at the same rate of $25. So then we divided by the sum of the numbers, actually the number of the number of the values, so equal to the 471 divided by 26. Here is the number we get for the weighted mean. That means averagely at this company the people are paid at the $18 per hour. Again, we are talking about all of these measures we try to learn are helping us to find the center of the data. So mean can help us find the center of the data, but the problem with the mean is because mean consider every data, so mean is easily influenced by several few very large or very small data. So sometimes mean cannot represent the whole data very well. That means mean sometimes cannot help us find the center of the data. That's why we're gonna try to learn the next one, the median. Median is the midpoint of the values after they have been ordered from the smallest to the largest, or the largest to the smallest. So remember, if we want to find the median of our group of data, first we need to rank them from the smallest to the largest, or the largest to the smallest. So the property of the median. First, there is a unique median for each data set. What does that mean? Just as a median also is unique, there is only one median for a group of data. Okay, one median for a group of data. Second, it's not affected by extremely large or small values, and it's therefore a valuable measure of a central tendency when such values occur. This is better than the mean, because mean is easily affected by extremely large or small values. It can be computed for ratio level, interval level, and ordinal level data. Okay, examples. Examples are always the best ways for us to understand the concept. The age for the sample, a sample of the 5 college students are 21, 25, 19, 20, and 22. So how do we find the median for this set of the data? First, let's arrange the data in ascending order. So we get the 19, 20, 21, 22, 25, and the median is the middle of this group of data, middle one. So that's the median is 21. Okay, for this kind of the data, I mean this group of data has odd numbers, so we try to find the middle one is okay. How about what if we have the group of data with even numbers? So for example, the heights of the 4 basketball players in inches are 76, 73, 80, and 75. So how do we find the median of this group of data? First, arrange the data in ascending orders. We get 73, 75, 76, and 80. Then the median is the average number of the middle two values. So the median is 75 plus 76 and divided by 2, we get 75.5. So this 75.5 is the mean number of these two data. Mode. Mode is the value of the observations that appears most frequently. So for this, table, we can tell the mode is this one. For the observation, it appears or happens most frequently. Let's check another example. This example says the annual salaries of the quality control managers in a selected states are shown below. What is the model annual salary? So 60,000, appears most. 60,000 appears most. So we say the 60,000 is the model annual salary. Actually, you already seen that it's very complicated when we do the calculations to find out the mean, median, and the mode. Where using Excel, it's very easy quickly to find out the mean and median. You just follow these steps. It's if you get a group of data and from your Excel select the data and then data analysis, select the descriptive statistics, and then for the input range you type in the data, the range of the data, then indicated that the data are grouped by column and the label are in the first row. Then click on the output range. Well, you put any cell you wish, then click the summary statistics, then click OK. You can get the result like this. So the mean and median and mode out there, very easy, quick to find the result. But when we during the learning process, I strongly recommend you know how to calculate that by hand. Why? Because that's the only way help you understand the data and help you know where and when you can use those concepts. Okay, now we are talking about the relationships between the mean, median, and the mode. Actually, the relative positions. This slide is very important because in our exam, I'm gonna test some questions. Gonna test you about the relationship between the mode, median, and the mean, and their positions. Their different locations. For the first graph, we call the first graph the symmetric. For the symmetric, the graphs, there's a zero skewness. For this kind of graph, mean, median, and mode are exactly same. So there is no skewness for this graph, for this kind of distribution. For second graph, for this kind of distribution, the median in the middle, and the mode is smaller, and the mean is largest. and we call this positively skewed. Please remember, we call this kind of shape of the distribution positively skewed. Why? When it is positively skewed, that means the mean is largest one. Why? Because in this kind of situation, mean is affected by a few very extremely large values. We call this, this kind of shape, we call that negatively skewness. So for the negative skewness, the mean, the mode is greater than median, and the median is greater than mean. Okay, that's their relatively relationship among these three measurements. Okay, dispersion. A measure of location such as mean or median only describes the center of the data. It is valuable from that standpoint, but it does not tell us anything about the spread of the data. Do you remember in the first several slides we talked about the spread data with the example of the average annual salaries of the internet-related companies and pharmaceutical companies. For example, if your guide, nature guide, told you that a river had averaged 3 feet in depth, would you want to wade across on foot without additional information? Probably not. You would want to know something about the variation in the depth. Because for the river, maybe some spot is very very deep and some spot is very very shallow. You don't want to risk. The second reason for studying the dispersion in a set of data is to compare the spread in two or more distributions. Okay, we use those formulas to measure dispersion. First one, range. Range, how do we find a range? For a group of data, range equal to the largest value minus the smallest value. We use the mean deviation, and we use the variance and the standard deviation. I'm gonna introduce all of these formulas, explain all of the formulas in the following slides. Range only considers the two values of the group of the data, so that's the weakness of the range. The variance and the standard deviation just overcome this weakness. Both variance and standard deviation considering the deviation from the mean. So for the population whose values are near the mean, every individual specular values are near the mean, the variance and the standard deviation will be very small. For populations, those values are dispersed from the mean, the population variance and the standard deviation will be large. So variance is the arithmetic mean of the squared deviation from the mean. Standard deviation is the square root of the variance. Both variance and standard deviation are non-negative and are zero only if our observations are the same. Why? Because variance and standard deviation just check the deviation from the mean. So if they are all the same, means the mean are same. It means the mean is actually the values, so no deviation means the value of them are zero. For the populations whose values are near the mean, the variance and standard deviation will be small. For the population whose values are dispersed from the mean, the population variance and standard deviation will be large. Variance overcomes the weakness of the range by using all the values in the population. It is a little bit complicated to calculate the variance and the standard deviation, but if we just follow the steps, it will be okay. And again, I want you to know how to calculate the variance. Understanding the steps can help you understand the concept and its application. So it's very important. We use the sigma squared to represent the variance. It's the sigma squared is the population variance, The sigma is a lowercase Greek letter sigma. It's read as sigma squared. And x here is the value of an observation in the population. Mu is the mean of the population. We already know how to calculate the mean, mu. N is the number of observations in the population. So how do we find the variance? First step, we need to find out the mean of the population. Second step, we need to find the difference between each observation and the mean and square that difference. Find the difference between each observation and the mean, because again, the variance is try to find out how the data spread, the deviation, each value deviate from the mean number. Third, sum all the squared differences found in step 3. We sum all the squared differences found in step 3. We use the sigma to show this operation. Fourth, divide the sum of the squared difference by the number of items in the population divided by the number of the observations. Let's check an example. The number of traffic citations issued during the last 5 months in this county, South California, is reported below. What is the population variance? So first step, we find the mean number. We add all these values up. That's the sum x. Then divided by the number of the value. In total is 12. So n is 12. Then we get 29. The second step, we find a difference between each observation and the mean. So that means we're going to use each number and minus the mean. See, we use each value minus the mean. Then we found the numbers here. Then we're going to square it. We're going to square each steps. And then we found out the total, the sum. We sum all of the numbers up, we get the 1488. Then we use the 1488 divided by 12. We get 124. So what does 124 mean? This 124 means for this group of the data, for this group of the data, there's the square difference between each data to the mean is 124. That is a number is hard to understand. That's why in the later slide we're going to introduce the standard deviation, because standard deviation actually is the square root of this number. So under square root of the number, that is when we get the standard deviation, you will more clearly to see the average difference for the each value away from the mean number. Just now we introduced the variance for the population. How about the sample variance? There's a little bit different. First, we use the I squared to represent the sample variance instead of the sigma squared. And then we use the n minus 1 for the denominator, okay, instead of the n. So how do you calculate the sample variance? Here is the example. For the hourly wages for sample of the part-time employees at Home Depot are 12, 20, 16, 18, and 19. So first step, we find out the x bar. X bar is sample mean, right? So we add the 12, 20, 16, 18, 19 up, and then divided by 5, we get the x bar. Second step, we use each value to minus the sample mean. Use that is x minus x bar. So we get each numbers, and then we square them, and then we sum these numbers up. We sum these numbers up means 25 plus 9 plus 1 plus 1 plus 4. Then we get the 40. Then we use the 40 divided by n minus 1. That is 40 divided by 5 minus 1. Then we get a 10 in dollars squared. That is the sample variance. Okay, finally we get at the standard deviation. Actually, to check the dispersion of the data, most of the time we use standard deviation. Standard deviation is square root the variance. Again, I just said variance is hard to understand, but if you square root that, so you can find out for a group of data how far away for each value away from the mean number. Then you can tell if this group of data is widely spread or it's very close to the mean number. Why we want to find the standard deviation? Because if the standard deviation is very small, that means every value in that group very close to the mean number. That means the mean number is very representative. But if the standard deviation is very large, that means each value is far away from the mean number, and then that means the mean number is not so representative for the whole group of data. Okay, empirical rule. For symmetrical Bear-shift frequency distribution, you remember the relationship, the relative locations, positions of the mean, median, and mode. For symmetrical Bear-shift frequency distribution, that means the mean, median, and mode are the same. Okay, for this kind of the distribution, the data distribution, about 68% of the observations will lie within plus and minus 1 standard deviation of the mean. About 95% of the observations will lie within plus and minus 2 standard deviation of the mean. Practically all will lie within plus and minus 3 standard deviation of the mean. Check this out. Please read this carefully. If you have any questions, please send me email or call me to ask, because this part is fundamental for the later chapters, and also this part will be in our exam. Okay, last part, arithmetic mean of grouped data. In the previous slides we introduced the mean for ungrouped data, and here is the mean of grouped data. The grouped data is after we put the data into the frequency distribution. Means we classified the data, then we call those data grouped data. How do we find the mean numbers for those data? This is the formula. Okay, we use x bar, means the sample mean for the grouped data. This m is the midpoint of each class. F is the frequency in each class, so we just sum all the frequency in each class times the midpoint of each class, then divided by the total number of the frequency. Say is this table formula. This is the frequency distribution, so we find out the midpoint for each class, then use the midpoint times the frequency. Once we get that product, we add all the products up. After we add them up, we divide it by the number of the frequency. So here is 1845 divided by 80. There are 80 observations in that group of data. Please pay attention how do we calculate this mean of the grouped data, because there is one similar question in your homework. This is the formula for the standard deviation of the grouped data. Okay, S is a symbol for the sample standard deviation, so that's equal to the square root. And we also use a midpoint minus each value of the group, minus the mean number of the data, then times the frequency, and squared it, and then times the frequency, then sum them up, divided by n minus 1. N is the total number of the observations. About the standard deviation of the grouped data, please check this example. This is the last slide. This slide shows you the steps how do you find out the standard deviation of the grouped data. So for the different classes, we find the midpoint first, and then we use the midpoint minus the mean of the group of the data. Okay, so this x bar, how do we calculate this x bar? We calculate the x bar use this formula. Remember, we use this formula find out the mean of the group data, and then it's here use the midpoint minus each one, and then square it, then times the frequency for each frequency, then sum them up, we get this number. This you just try to try to understand it. This whole calculation process is too complicated, so I won't require this part in the exam. Again, if you have any questions, please send me email. Seems there are a lot of the information and knowledge we need to learn in these chapters. So, if you have any question, please do not hesitate to ask me about it.